Welcome back, Algebrats. This is lesson 81. We're going to be talking...
Michael, what are you doing?
Mom, I told you I'm recording lessons for my algebra students. Please. I love you.
I love you.
Okay. Bye. Okay, that was a just slight interruption. My mom, technically I don't live in my mom's basement. I just wanted you to know that, okay? All right, lesson 81, here we go. We are going to solve systems of equations with graphical solutions. So in the past, we've solved a system of equations like this: y equals x plus 1, y equals negative 2x plus 4. And then we can use substitution. So what we can do is we can substitute this guy in there, right for y there. And then when we rewrite our equation, it looks like this: x plus 1 equals negative 2x plus 4. Then we bring this guy over here and add 2x to both sides, so we get 3x plus 1 equals 4. Subtract 1, 3x equals 3, x equals 1. So if x equals 1, y equals x plus 1, so that's 2. So we can solve it with substitution, but there's another way. I told you we can solve it by 3 ways. These are the 3 those are really big fingers. Substitution, elimination, and now graphing, okay? So we're gonna do this by graphing. So we're gonna write the same equation down here. So I'm gonna write this equation here, y equals x plus 1. I'm gonna pick some xy values. So if x is 0, y equals 1. If x is 1, y equals 2. If x is 2, y equals 3. Then I'm gonna pick another, and then I'm gonna graph this other one, negative 2x plus 4. So let's do our xy chart. If x is 0, y is gonna be 4. If x is 1, y is gonna be, let's see here, negative 2 times 1 plus 4. So y equals negative 2 plus 4, so y equals 2. When x is 2, y equals 0, because negative 2 times 2 is negative 4, plus 4 is 0. Okay, so if I graph these, I'm gonna go over to my nice little graphing calculator here. Y equals x plus 1. So there's one of my equations. Here's my other equation. Y equals negative 2x plus 4. You can do it this way, and we talked about the slope-intercept form, and we'll review that. I'm gonna show you that in this lesson as well. But look at this guy. This is pretty sweet. So this point right here is where these 2 lines intersect. These 2 lines represent these 2 equations over here, okay? So this point is true for this equation, and this point is true for this equation. So this xy value is what works in both equations. So what's this xy value? Well, it's 1, 2. So x is 1, y is 2. Okay, and that's what we had here. X is 1, y is 2. So you can write x equals 1, y equals 2, or this is what the cool kids are doing, 1, 2, and that's your solution. Boom. So this is using an XY chart to graph these 2 equations. We're gonna review the slope-intercept form. Okay, so we're gonna try another example. The example 2 in the book is a little different, so we're gonna try this example 1b. Let's just do the same one. So y equals x plus 1, and y equals negative 2x plus 4. Okay, these are our 2 equations, right? So slope-intercept form is this: y equals mx plus b. M stands for slope, probably because of all the letter M's in the word slope. It's bothersome. B stands for y-axis intercept. This is where the line crosses the y-axis. Remember, the y-axis is the vertical axis. Okay? So slope, if it's written in this form, if y is by itself, this reveals all the secrets of the line. It reveals a point on the line, and it reveals the slope. So if you have those two things, you can draw the line. So you can go to the y-axis to this location, wherever B is. Like if that's a 5, you can go up to 5 and put your pencil there. And then you just follow the direction of the slope. Well, the direction of the slope is rise over run. So the top number of your fraction is how much you rise, and the bottom number is how much you run. Okay, well, if you look up here, look at this number. Well, first of all, there's no number here in front of x. So m is the slope, which is the number being multiplied by the x. Well, there's no number in front of x, so we're going to put a number there. You can always put a 1 in front of anything. But that's not it. There's no fraction either. So how do you make a fraction out of a whole number? You just put it over 1. So now we've got our rise and run. So our slope is 1 over 1. So this is rise over run. So we're going to go up 1, right 1. So positive 1 over positive 1. Okay, and then our y-axis intercept is 1. Okay, so that's where we plot this point. So this guy goes right there. All right, and then we're going to go up 1 over 1. So this means up 1 and then right 1. Okay, so from up here, you're going to go up 1, right 1, up 1, right 1, up 1, right 1. Okay, then you can just connect the dots because these lines go on forever. All right. So that's that line. So now let's look at this one. Let's figure out our M and our B for this guy. So M is this number, but it's not a fraction. So fractionate it. Fractionate. That's a word. So -2 over 1. So what you're doing is you're rising -2, or in other words, you're going down 2 and positive 1. So you're going to go right 1. But from where? Well, that's where your intercept comes in. So this guy is your y-axis intercept. So that goes right there. So 4, you start at 4 and you go down 2 over 1. Down 2 over 1, down 2 over 1. At this point, you can connect the dots if you want to, but I think you already noticed that this guy is where they intersect, and that is 1, 2. So slope-intercept form just simplifies the process, but the trick with slope-intercept form is remembering which is which and what's the slope and what's the intercept. But once you get it down, you can graph equations really quickly, and it works really well. So let's do example 2. Here we go. Y equals 2 and y equals x. Whoa, that's a little weird. Okay, so our slope-intercept, that's kind of weird. So in other words, you could say this is y equals 0x because there's literally 0 x's in there. So you can say 0x plus 2. So your slope is 0 and your y-intercept is 2, okay? And this guy is y equals 1x plus, there's no constant, so you can say 0. So in this one, your slope is 1 over 1 and your constant is 0, or your y-axis intercept is 0. So if I were to graph this equation, let's graph this bottom equation first. B equals 0, that's the y-axis intercept. So B is right there. And 1, 1, so up 1 over 1, up 1 over 1, up 1 over 1. So that's kind of nice. All right. Okay, and then this guy, your y-axis intercept is 2, so it's right there, and your slope is 0. So if you think about rise over run, it's up 0 over whatever. But remember, the shortcut for y equals something is a horizontal line right at y equals 2. So right there, and look where it crosses, right there. So what's your cool answer? 2, 2 is your final answer. All right, here's example 3. So we're going to solve by graphing. Let's try using the slope-intercept form. Y equals x plus 2, y equals x minus 1. So what's your slope and what's your intercept? Well, the slope for this one, we'll do a certain color here. So m equals 1, so 1 over 1, and b equals 2. All right? Over here, your m is still 1 over 1, and b equals -1. So let's graph this green one first. B is -1, so that's where we start on the y-axis intercept. And we're going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Okay? So I'm not going to connect the dots because really you don't need to, because you're just looking for where they intersect. So let's graph the blue equation now. We're starting at 2, and then we go up 1 over 1. What do you think is going to happen? These guys are parallel. So guess what the solution is? What's the solution? The solution is no solution. So when you have two parallel lines, there is no solution. So this brings us to 3 different categories of equations. So most of the time, what you're looking for is you're looking for what we call consistent equations. Consistent equations. This is where you have 2 lines intersecting in a nice spot there. Okay? So consistent equation, you have one solution. So whatever that is, x comma y. Okay, you have an x and y value that work in both equations. All right, and then you have what's called inconsistent equations. That's right, inconsistent equations. This is where you have 0 solutions. And this is when your lines are parallel. So these are parallel lines. So you can spot parallel lines by noticing that these guys have the same slope. So same slope means parallel lines. All right, then you have a third category, and this category is called dependent equations. And really, these are still considered consistent equations. So this is where you have the same slope and the same y-axis intercept. So in this case, it's really just the same line. I'm going to give you an example. So let's say we have 2 equations, y minus x equals 2, and 2y minus 2x equals 4. So the first step to solving by graphing is to put these in slope-intercept form. So slope-intercept form is just y by itself. So y equals, get the x over there, x plus 2. And if you get this y by itself, then you get, let's get rid of the x, so you get 2y equals 2x plus 4. And then if you divide everything by 2, y equals x plus 2. So if you look at these 2 equations, they're the same. So when you graph these 2 equations, they're just going to be on top of each other. Dependent, when I think of dependent, I think of clingy. Like a child and his mom, they're very clingy, so they're very clingy. So kind of like if you lived in your mom's basement so that would be dependent, like you're really dependent on your parents because you live in the same house. But the same line. So that has nothing to do with my life, okay? I'm very independent. All right, so this is my third category. So I have 3 categories. 1, consistent equations. 2, inconsistent equations. And 3, dependent equations. So that's lesson 81 complete. Good job.
Flack math! Give me some math and I'll give you some flack. Flack math!